Hi, welcome back to our third video for 5.5, data collecting and modeling. In this example, we're just going to look at an equation that models the height of the Ferris wheel. So it's going to model the height above the ground after t seconds. So this is our sine function that models that height. All the question does want us to do is graph the function using graphing technology and then determine some things like maximum and minimum height, things that we can get from the graph. All right, so let's begin. We'll have to take this, enter it into our graph on Desmos. I already have mine loaded up right here. Okay, you can put yours in your TI-84 or on your Desmos app. All are fine. Okay, there is our graph. So I can see that it looks like this Ferris wheel starts at a minimum and then works its way up to the top at a maximum. And it looks like it takes a little over 100 seconds to get one full rotation. So it's probably 120 seconds, a total of 2 minutes for one cycle. Okay, let's start part B. So it says determine each of the following. So the max and min. So the max height, I can get that real easily. On Desmos, it happens at 60 seconds. It's 22 meters. The minimum happens at 0, and it happens again at 120. So those are at 2 seconds. Or so, yeah, those are at 0 and 120 seconds. The height is only 2 meters. That makes sense because from 2 to 22, that's a total distance of 20. Half of that is 10, so that's my amplitude. And the middle of these two values, if I add them up, I get 24 and divide by 2, I get the center line. So you can see there's an average here of 12. That's our center line in the equation. Okay, so let's move on. Double I, we have the height of the rider after 30 seconds. So I can actually get that on here if I just trace this out here. 30 seconds, we can see we get a height of 12. Okay, at 30 seconds, height is 12 meters. Okay, I'm going to show you how you could calculate that using the equation. So we just use the graph, but we could also do this algebraically. Plug in 30 for time into the function. So put 30 for t. Those are going to cancel out to give 0. So in fact, like because 30 minus 30 is 0, we have 3 times 0. That makes all of this 0. And sine of 0 on the unit circle, that's at the very bottom. Or sorry, that's at right here is sine of 0. The y value is also 0. So I know this whole thing just makes a big 0. Multiply that 0 by 10, and that makes all of this 0. And we're left with just 12. Okay. So visually you can see that it's just going to be 12, but if you want, you can plug a few things in. Okay, just to show it one step at a time. So 3 times 0 is also 0, so we'd have 10 times sine of 0. And that's also 0. You can see how we get the 12 for the height. Okay, and that does match up with the graph. Okay, and then part 3, or 3i, we have the time required for the Ferris wheel to complete one revolution. Well, that's pretty easy. We're starting at a minimum, and we finish at a minimum. So it looks like it takes 120 seconds. Okay, or we can put that in terms of minutes, and we could just say 2 minutes. Okay. We could also calculate this using the equation because I know that k is equal to 3. The period is always 360 over k. 360 over 3 gives me 120. So it would be 120 seconds. All right, that's it for this lesson. I hope you guys found all these videos helpful. I will see you guys later.